Hi guys, we've used trigonometry to find missing sides, but if this divided by this is really consistent for that particular angle and it actually defines that angle, then there must be a way of getting from the sides to the angle. And I'd like to investigate that today. So first of all, as per usual, let's label the sides up. So this one's on the opposite side, so that's the opposite. And this one's next to or adjacent to the angle and doesn't touch the right angle. So that's the adjacent. So if we were thinking SOHCAHTOA, and remember that first letter we don't really need to help us find out this bit. I can see O and A is clearly this one. So I'll set up my algebra triangle. Remembering the middle letter is at the top. TOA. Right, I have O and I have A, so I must be finding T. So what I'm going to write is tan x is equal to opposite divided by adjacent, so that's 8 divided by 10, so 8 divided by 10. So, is there a way now of being able to find the value of x? Well, yes, there is. We find something called the inverse tan, sometimes known as the arctan. And the way we do that is we say x is equal to, now if I find that instead if I've got tan on this side, I'm going to have the inverse tan on the other side. Just like if something's times in on that side, it divides on that side. If something's adding on this side, it takes from that side. So we're going to look at the inverse tan. And the way we write inverse tan is tan to the minus 1, 8 over 10. Now you've probably seen that before, because if you look at your calculator, you can see that tan to the minus 1 is directly above the tan button. And anything that's directly above that's yellow can be found by hitting that shift button. So one way that we could write this in terms of the buttons we press on our calculator would be pressing shift tan and then putting 8 over 10 in. So if I put that in, shift tan 8 over 10, close, oops, I've used the fraction one, so I need to move a little bit just before I close the bracket. That gives me 38.6598. So remember, we're thinking about three significant figures if we're not quoted. So 38.7, and then that will be degrees, because that's the units of measurement that we're dealing with. So if I looked at a different one, I'll draw this one that way up. Remember, this is all to do with right angle triangles, just like Pythagoras was. Now, if I said that is 12 centimetres, and that is, what should we say for that? 7 centimetres. So first of all, I've got to identify the sides again. This one's easy. Hypotenuse, always the longest side, doesn't touch the right angle. And this one, the side that's next to the angle, but isn't the hypotenuse, remember the word meaning next to is adjacent. So, I've then got to think about SOHCAHTOA. SOHCAHTOA. Realising that those are not going to help me work these out. But I can see there I've got A and H. So I'll go for my cos algebra triangle, remembering the middle letter is the one at the top. and I'm given A and I'm given H. Here's my A, here's my H. So I must be finding the cos. So remember, cos is attached to the angle, so cos x is equal to adjacent, which is 7, over hypotenuse, which is 12. If you put them in the wrong order and then try and do shift and cos, you'll find that it won't work. So that if you get an answer it says maths is broken or it doesn't work, it's because you put these in the wrong place. If you put 12 over 7, you can't get an answer. There is no answer for that. So you have to make sure that you put them in the right way around. Adjacent divided by hypotenuse. Hypotenuse is always the longest one. That's how we remember it. Cos and sine should always be a vulgar fraction, so not top heavy. Anyway, I digress. So we've got x. So if we're cosing on this side, we are inverse cosing on that side. The same as we did with the tan on the previous one. And in order to put that into my calculator, I can say x is equal to shift cos 7 over 12. If I put that in, so I've got shift and cos this time, 7 over 12, close my bracket off, equals 54.3 degrees to 3 significant figures. So we are using much the same mechanisms as we've used in the past. We label the sides with opposite, adjacent, hypotenuse which are involved. If the side's not involved in the question at all, we don't label it. We write down SOHCAHTOA, and that should clearly tell us which of those we are using. We write down the algebra triangle with the middle letter being the one at the top, and we set out that we're finding the cos or the tan or the sine if the question held that. The key extra step that we've come across now is that if it's cosing on this side, in order to undo that we have to inverse cos the other side. An inverse is an undoing operation, so we're saying if I undo the cos I need to find the inverse cos, and here undoing the tan gave me the inverse tan of that side. And from then on it's just shift and tan and shift and cos and shift and sine to give you those letters, those things above the sine, cos and tan that are accessed via that shift button. 3 significant figures are your answers. I think you're going to do really well with this. Okay, thank you.